Hello, and welcome to the Johnson Controls Blue Water webinar for March 2023. I am Craig Hanna, and I am grateful to serve as the engineering manager of the Johnson Controls Water Infrastructure Technology team. Our team of subject matter experts is dedicated to designing, installing, and commissioning projects that reduce water loss, that increase water utility staff efficiency, and that decrease operational and maintenance expenses. Our team exists solely to provide your water utility with the tools that it needs to run smoothly. I'd like to now introduce to you two of my teammates, Audrey Noel and Jonathan Gunn. I'll ask Audrey to go first. Audrey, would you please tell us more about yourself and how you help water utilities?
Absolutely. Thank you, Craig. I'm Audrey Noel, Director of the Water Infrastructure Technology team here at Johnson Controls. I have 7 years of industry experience, a Juris Doctorate with an emphasis in environmental law, and decades of experience in operations. I have the privilege of leading the team from the sunny shores of Huntington Beach, California, but I couldn't do it without our very knowledgeable and talented market manager, Jonathan Gunn, who offices just 2,700 miles northeast of me in Canandaigua, New York. Jonathan, would you please tell us a little bit about your experience, please?
Yeah, thanks, Audrey, and we'll meet up for lunch later. Yeah, I'm John Gunn. I'm a market manager, as Audrey said, and I have 13 years in the industry. And like Craig, I'm heavily involved with the American Water Works Association, including as the current chair of the Customer Metering Practices Committee. And I also co-author a number of manuals, publications, and articles. So great to be here with you this morning. For those of you who have been with us, welcome back. And I mentioned this briefly last month, but I did want to bring it up one more time. For those who may be newer to the series, or maybe if you've been with us since the beginning, and maybe there were one or two you weren't able to make, every webinar that we've done so far is now up on the official Johnson Controls YouTube channel. And so if you just go to YouTube and search Johnson Controls Blue Water Webinar, that channel should pop up. And more specifically, you should see a playlist called Water Solutions. And that's where you'll find not only every webinar that we've done, including this one should be posted usually within a week or so. So you'll have every webinar we've ever done. There's also additional what we call bonus content. So there's additional customer interviews. There are additional videos about things like performance contracting, just quite a cache of information there. So if you haven't checked it out already, I highly recommend you do. A lot of great information there. I also did want to mention that if you are attending the Illinois WaterCon conference next week in Springfield, Illinois, we do hope that you'll stop by booth number 438, and Craig and I will both be there. We'd very much like to meet you and talk to you, and see how we could potentially help you, or just do an introduction. So with that being said, Craig, I'm going to turn it back to you for the agenda.
All right, well, thank you, Jonathan. We'll start our webinar today with a very short but important talk about safety. A water utility worker in Illinois drowned while working in a vault last month, and we'll discuss that tragic incident and provide you with some tips on how you can avoid being in that situation. We'll next share some invaluable lessons that we have learned over the past 2 decades of installing water meter and AMR and AMI system projects. I know that your water utility will benefit greatly from our experiences. Following that, we're very happy to have Dave Rubin from Aclara as our guest today. Dave will be providing us with an update on what is new with the Aclara STAR AMI system. Before we start our discussion, I should explain the fire hydrant photo that you see. We had a week of very cold weather come through here last month, and I noticed the blocks of ice hanging down from the fire hydrant serving my neighborhood that indicated a leaking hydrant valve. So I sent an email to the water department, and they sent a crew to repair the hydrant valve the very next day. So I'd like to thank the Lubbock Water Department for their very prompt response. Now I'm going to ask Audrey to talk about that heartbreaking loss last month in Illinois and why you need to be extra careful working around underground vaults. Audrey?
We're saddened to report that a 20-year-old utility worker in Illinois drowned on February 23rd when he was attempting to repair a water main break that occurred inside an underground vault. The news report stated that the vault in which he was working was only 6 feet, which certainly seems like a confined space. It appears that one of his hands became wedged between some pipes, and the vault filled with water before his colleagues and the first responders could manage to free him. We extend our deepest sympathy to this young man's family, friends, and coworkers for their loss. When it comes to underground vaults, the very first thing that water utility workers should think about is recognizing a confined space. OSHA defines a confined space as being any space that is large enough and so configured that an employee can bodily enter and perform assigned work that has limited or restricted means for entry or exit, such as storage tanks, vaults, and pits, and any space that's not designed for continuous employee occupancy. The next two process flow charts were taken from an OSHA confined space entry course. We strongly encourage you to learn these charts for your own safety. We should mention that OSHA explains limited or restricted means for entry or exit as one in which the path by which the entrant must travel out of a space to reach an area of safety must not present a physical barrier which would impede self-rescue. Regarding whether a space is designed for continuous human occupancy, OSHA says that the definition properly places the focus on the design of the space, which is the key to whether a human can occupy the space under normal operating conditions. If when the space was originally designed or subsequently redesigned, the designer took into consideration that humans would be entering the space and provided for the human occupancy, such as provided ventilation, lighting, sufficient room to accomplish the anticipated task, then the space would be designed for employee occupancy. This handy process chart from the OSHA Confined Space Entry course is designed to help you determine if a confined space requires a permit for entry. This chart explains why so many structures that are found in a water distribution system require an access permit. It's very common for a confined space in a water distribution system, such as an underground large water meter vault, to be oxygen deficient. And moreover, the sudden flow of water from either a break in a pipe or a failure in a fitting in a water meter setting could quickly engulf a worker and entrap them. There may also be numerous foot and hand entrapments in an underground large water meter vault, and depending on the time of year, extreme cold or heat can create an additional hazard to a water utility worker. Here's a great example of an underground vault that's not a confined space, and it's one of the nicer vaults you'll ever see. The vault has two hatch doors with two working pneumatic struts that keep the door open. Both hatch locks are in good condition, and they keep the hatch doors in the open position. The vault's rather shallow with an approximate depth of under 6 foot, and the vault is exceptionally clean. No trash, poisonous insects, snakes, rodents, or drug needles can be found. The setting's in good condition. There's only 3 things we would recommend changing in the setting, and you can send us an email at bluewater@jci.com if you want to know what they are. There are no air quality issues with this vault, and there's no entry or exit limitations. Regardless, you still need to plan your entry and egress carefully. If the unthinkable happens and there's a break, will the force of the water knock your ladder to the ground? Will the water knock you to the ground too? Will you be able to find the ladder, reposition it, and climb out of the vault before the vault fills with water? Is there something inside the vault that could possibly entrap you? Next is the best example of a confined space that we can share with you, and no one should enter this confined space for any reason. I literally shudder every time I see these photos. The vault lid is about 30 inches in diameter, so there's clearly a limited means of entry and exit into the space. Worse, no one bothered to keep the area around the vault clear, and the roots from the tree growing next to the vault have caused the walls to crumble, as you're going to see in the next slide. As one of our customers so eloquently said about a similar situation, this was a problem 30 years in the making. This collapsing large water meter vault could have been prevented if only someone had cut down the tree when it was merely a sapling. As you can see, the vault walls could collapse at any moment, and it looks like the vault ceiling is also buckling. While I truly admire the bravery of whoever took these photos, I must seriously question their judgment. That person was unaware as to how close they came to becoming a casualty, and for no good reason, too. In conclusion, follow the OSHA confined space guidelines. If you choose to enter an underground vault, make sure you have both the proper training, the correct tools, equipment, and any necessary permits. Always plan your entry and egress carefully. Your family, friends, and coworkers need you to be healthy and whole, and we want you here for the next Blue Water webinar. Craig, now that we've covered recognizing a confined space, would you please share some lessons learned about preparation for water meter and AMR, AMI system projects?
Well, thank you. I'd be glad to do that, Audrey, and appreciate that timely safety message. You know, those photos still scare me whenever I see them. Those walls could have crumbled and the ceiling collapsed on top of the worker who took those photos, and that person may have been crushed to death, but if they somehow survived the initial impact, they would have either drowned or would have been trapped for many hours, if not days, before they were rescued. But now on to our main topic. And if you spend any time around me, you know that I love classic country music. And one of my favorite songs is by Tracy Lawrence, and it's a song called Lessons Learned. I really wish that we could play the song for you, but I know Jonathan would probably storm out of the webinar in protest, and we really need him here. But I do love this song because it reminds me so much of my grandfather, who had a great influence on my life. And the central theme of the song is learning from life's experiences. And we printed the chorus of the song for you because it pretty much summarizes our webinar for today. We want to share some of those invaluable lessons that we've learned through the years with you. And one of the most valuable lessons that we wish to share with you is the importance of selecting partners who are both experienced and trustworthy. This is the primary reason why we choose to lead with education in our projects. We enable you to make informed decisions about what will work best for your utility. The AMR or AMI system that you select will be with you for the next 2 decades. Is it backwards compatible with your existing water meters, or will those assets need to be replaced? If you select a mobile AMR system, can it be migrated later to an AMI system without replacing those endpoints? If you select an AMI system, can it support the smart cities concepts and Internet of Things or IoT devices and applications that your community may soon desire? We encourage you to carefully read the endpoint warranty terms from the network provider, especially for those AMI systems that communicate via cellular networks. Are those warranty terms acceptable to you? And while the network you want may have a lower first cost, is it more expensive than other networks in terms of life cycle cost? We encourage you to verify the references given by the network provider unless you select us to develop your AMR or AMI system project, because we do that work for you. The same also applies to water meter manufacturers and their local distributor. Do you have confidence in the water meter manufacturer? Do you trust their local distributor to provide you with the prompt service and support that you need? More importantly, do you enjoy doing business with their distributor? If you hire an installation contractor, do they have all the necessary skills, labor pool, training, licenses, safety programs, customer notification and scheduling processes, inventory management programs, and work order management systems to successfully complete your project? Remember, a water meter and an AMR or AMI system project is really 2 different projects that occur at the same time. There is the physical installation of the water meters, and there is the data management project, in which you must accurately capture the data from the old water meters, from the new water meters, the endpoints, and then enter all of that data correctly into the utility billing system. Now, there are many benefits to using a performance contract for your water meter and AMR or AMI system project. We hope that you choose that method, and if you do, we encourage you to make certain that you choose an energy service company or ESCO that is both experienced and trustworthy. Do they have a team of subject matter experts who are focused solely upon water meter and AMR and AMI system projects? Carefully check their credentials of who will be developing your project. Are they licensed professional engineers, certified project management professionals, and certified energy managers? Do they keep current with the latest technologies by being involved in both AWWA and in the rural water associations? And this is a key point for you to remember. A water meter and an AMR or AMI system project affects virtually everyone in the community. Can you really afford to be someone's first rodeo just to save a few dollars? And in keeping with the theme of not being someone's first rodeo is the principle that it sometimes hurts to be on the bleeding edge of technology. And many of us, myself included, who enjoy being early adapters are eager to have the latest systems, software, and applications deployed in our utility. We know that pilot projects can be both fun and challenging, but there can be a high degree of risk with a system-wide deployment of a new and unproven technology. In my career, I've recommended to 3 different utilities that they not move forward with a system-wide deployment of a new and unproven meter reading system. Unfortunately, each of the 3 utilities decided to go with a very risky technology, and it ended very poorly for the utility each time. Caveat emptor is a Latin expression that means let the buyer beware. At Johnson Controls, our team does the research and vetting for you because we must financially guarantee its performance. If you choose not to work with us, however, you must still do your homework and thoroughly qualify any new technology or software that you are considering purchasing. One time, I was researching a new automated leak detection system, and I started calling the references that were given to me by the provider. And when I called the 3rd reference on the list, the person on the other end said, "Why are you calling me? We hate that technology. It doesn't work, and we wish that we had never bought it." Now, I don't mean to be insulting, and there are many companies and sales professionals who are honest and trustworthy. What I am trying to say is that you should trust but verify. If something is too good to be true, it probably is, and in the water industry, you always get what you pay for. We have heard some very questionable things through the years, such as no interference, 100% read rate, every meter, every day, there is cellular coverage over the entire area, and our all-time favorite, cellular signals do not attenuate ever. If you make those claims, your network has somehow achieved perfection, which is simply impossible. Anything designed and built by man involves multiple trade-offs, and it will have weaknesses. And while there are many very good networks out there, absolute perfection can never be obtained, much less sustained. And there may be cellular coverage over the entire area, but at what signal strength? What are the alternatives available to you if there are gaps in the cellular network coverage? The moral of the story is the laws of physics are both universal and unbreakable. If your utility billing system software is not up to date with all the necessary upgrades, there is a very high probability that your AMI system project will be delayed until you either make those upgrades or you replace the existing system with a new utility billing software. And depending upon the number of upgrades needed and the time required to complete those upgrades, those delays can be very costly. They can also bring some much unwanted attention to your department from your board or your council. And while we're discussing utility billing systems, never replace your utility billing system while also performing an AMR or AMI system project. That is a recipe for catastrophe. Every billing system has errors in it because people are human and we all make mistakes. If you replace the utility billing system software while performing an AMR or AMI system installation, those errors will most likely be entered into the new software and continued indefinitely. We strongly recommend installing the AMR or AMI system first and then replacing the utility billing system software. The errors in the billing system should be found and corrected as a part of the AMR or AMI system installation. And you can then have confidence that the data going into the new utility billing system software is accurate. Another thing involves inactive accounts. You need to decide what work is to be done at those vacant properties. Do you risk installing a new water meter and an AMR or AMI system endpoint at a vacant property, knowing that it may be many months or even years before that residence is occupied or a new business is opened at that site? Should you perhaps wait until a new account is opened at that property? There are advantages and disadvantages to either approach, but regardless, you need to decide before you finalize that scope of work. Now, I know this point seems rather basic, but we are of a situation with a project that was executed by one of our competitors in which the water utility assumed that there was a joint use agreement in place with the local electric provider. Our competitor planned on using the electric utility poles to mount their collectors and repeaters. Unfortunately, no such agreement was in place, and for reasons unknown to us, an agreement could not be negotiated. Worse, the problem did not surface until project installation, and the AMI system provider had to scramble to redesign the entire network and locate new assets and erect towers and poles onto which to mount collectors and repeaters. I can tell you from experience that is neither cheap nor easy to erect a communications tower. Now, if you work with us to develop your AMI system, we have very rigorous performance expectations that must be met. If those expectations aren't met, the AMI system provider must provide the additional infrastructure or other improvements at no cost to your utility. If you choose not to work with us, however, we still encourage you to carefully review the radio frequency propagation study that you receive from the provider. First, ask yourself if the proposed level of coverage meets your expectations. If it doesn't, work with the AMI system provider to design a network that is acceptable to you. Second, confirm that it is both physically and legally possible to install a collector, repeater, or router at each location that is being recommended by the AMI system provider. And if not, promptly bring this to the attention of the AMI system provider. Don't forget that you may also need to run electrical power to that site. And third, is the number of endpoints being read by a repeater, collector, or router worth the cost of purchasing, installing, and maintaining that device? For example, one of our projects was located on a barrier island. The northeastern side of the island was densely populated and ideal for an AMI system network. The southwestern side of the island was mostly cattle ranches and very sparsely populated. In order to read just 108 endpoints on the southwestern side of the island, we would need to purchase and install 5 network devices. Is having 108 endpoints on the fixed network AMI system worth the cost and additional infrastructure? For some utilities, the answer is absolutely. But for other utilities, they may choose to read those 108 endpoints with a mobile collector. Now, I want to thank you for letting me present some of the lessons that we've learned for AMR and AMI system preparation. I'd like to pause for a minute and ask if you have any questions about the topics that I covered. And you can use the questions module on your console if you have any questions that you'd like to add.
Craig, I see one here came through. It's what is meant by performance contracting for AMI?
All right. Performance contracting means that a service provider will create a baseline of your existing utility performance and then develop a series of improvement measures that will generate additional revenues for the utility or will reduce operational and maintenance expenses. And those increases in revenue and decreases in expenses will be used to pay for the project over a period of time. And the benefits have to be measured and guaranteed. And if the company offering the performance contract doesn't meet those projected benefits, then they must make up the difference. And is there anything you'd like to add to that, either Jonathan or Audrey?
No, I think you covered it well. And the only thing I'll add is, I mentioned the water webinar playlist on YouTube. We have a whole video dedicated to that as well. So I would definitely recommend that you go and look at that as well. We do a much deeper dive than what we can take the time to do here.
Well, thank you. That was a great question. And now I am going to ask the chair of the AWWA Customer Metering Practices Committee to talk to us about lessons learned about water meters and AMR and AMI system installations.
Well, thank you, Craig. Current chair, you're the former, so once removed. So, no, thank you, Craig. So continuing on with some other lessons learned, it's been our experience that sometimes problems can arise whenever you attempt to connect a mechanical encoder register to a new AMI system endpoint. Neither we nor the meter manufacturer could explain why, but all of the mechanical registers suddenly stopped working on one of our projects when the register cables were spliced to a new AMI system endpoint. There have been a handful of other projects as well where we've attempted to connect an existing encoder register to an AMI system endpoint only to find that they were not compatible despite being listed in the manufacturer's compatibility guide. Unfortunately, in these situations, you have limited choices unless you want to manually read that meter going forward. But another thing to note is the difference between pulse encoder and absolute encoder registers. And this is something that we talked about in one of our other webinars. If there's a mixture of these register types in your distribution system and you intend to leave a number of these devices in service, we recommend converting those pulse encoder registers to absolute encoder registers whenever possible. There are a couple of reasons for this. The first is that pulse encoder registers cannot detect things such as reverse flow or theft of service events, whereas absolute encoder registers can. Second, your utility will likely need to stock two different types of endpoints if you leave both types in service. One endpoint for pulse encoder registers and a different type of endpoint for absolute encoder registers. You'll also need to train your meter technicians to recognize the difference between a pulse encoder register and an absolute encoder register so that they can install the correct type of endpoint given the register at a specific service. These challenges are quickly resolved if you simply convert everything that's pulse encoder over to absolute encoder. I think a lot of people on the call here to know that we've been living through a time of near constant change in the meter industry for the last dozen or so years specifically. Some meter manufacturers have completely gone out of business, and revolutions in battery technology and computer processing that have made static meters an affordable reality have also caused many meter manufacturers to discontinue key legacy product lines such as traditional compound, turbine, and fire service water meters. It's entirely possible to find yourself in a situation where you have meters in your system that are 100% accurate, but those meters must be replaced because they have direct read registers, and since the meter manufacturer has discontinued that product line, you're unable to find new absolute encoder registers that can communicate with an AMI system. Your only choices are to either continue manually reading those meters or to replace those meters with the current production models that do have absolute encoder registers so that they can be read remotely. If you want to maximize billable water and sewer revenue and prolong the useful life of your meter, make sure that you follow the selection and installation guidelines contained in the AWWA M6 and M22 manuals and in the installation instructions for the meter manufacturer. And no, Craig and I don't get kickbacks for mentioning AWWA manuals that we help write. So just so no. We find hundreds of thousands of dollars for our water utility customers every year by correcting poor meter installations and from installing the correct size and type of meter for each application. And yes, the turbine meter that you see on the left was really installed upside down. Wouldn't you love to know the story behind that decision and moreover, how they read it every month? This is a problem that we find with many utilities. Compound meters and fire service meters each have two registers, one for the bypass meter and one for the main turbine meter. Both registers need to be read each billing cycle, and the usage from the bypass meter and the usage from the main meter should be added together in order to calculate total consumption. Unfortunately, it's not uncommon for us to find that some meter readers have been taught to only read one register for billing purposes. Similarly, it's not uncommon for us to find that only one register has been connected to a mobile AMR or fixed network AMI system endpoint if a system has already been installed. For a majority of mobile AMR system or fixed network AMI systems on the market today, both encoder registers need to be connected to their own individual endpoints in order to gather total consumption from the meter. Regardless of which mistake is being made, the utility is missing out on a substantial amount of billed water and sewer revenue by only reading one. This is another problem that we encounter periodically. A utility will choose to leave a newer meter leave newer water meters with absolute encoder registers in service, which is fine, but these registers may read in different units than the new meters that we are installing. For example, many of our customers build in hundreds of cubic feet at one time, and as such, the existing meters read in cubic feet. Over the years, utilities have recognized that it's hard for most people to visualize how much water is contained in a cubic foot. However, most people can visualize how much water is contained within a gallon-sized container. As a result, some of our customers choose to change from billing in hundreds of cubic feet to billing in thousands of gallons as a convenience to their customers. And then they have us install new water meters that read in gallons. In situations such as this, it is very important to make sure that the reading units for each meter be entered correctly into the utility billing system and into the meter data management software in order to generate accurate information, alarms, and bills for your customers. Polymer lids are great for use in AMR and AMI systems because they do not impede radio frequency waves to the same extent as a metal lid. We recommend that if you use a polymer meter box in an area that's prone to flooding, you use one with a locking lid. And if that's not possible, use a weighted lid that has been proven to be negatively buoyant. You don't want your meter box lids and your endpoints to go floating gently down the stream. Although there's a seemingly endless list of quality control measures that we follow at Johnson Controls, there are two that I'd like to point out given the photo on this slide. The first is that we insist upon using stainless steel nuts and bolts that have been treated with an anti-galling compound in order to prevent the fastener from corroding in most environments. For the meter in this photo, the installer used standard galvanized steel nuts and bolts, and you can see that these fasteners have corroded to the point of imminent failure. At the time this photo was taken, friction was the only thing holding this large meter setting together. The second is to always use stainless steel flat washers whenever installing an epoxy-coated ductile iron meter or other fitting. If you don't, the castellated edges from both the nuts and from the underside of the bolt head will scrape away the epoxy coating when the fasteners are tightened, and that will allow corrosion to set in on the now unprotected ductile iron body. Just a quick reminder, please continue submitting your questions through the Q&A. If you have any that you'd like to ask. So I don't see any more now at this moment, so I'm going to turn it over to Audrey to talk about some additional lessons that we've learned over the years. Audrey?
Thanks, Jonathan. Well, we understand that the AMI system projects affect everyone in the community, and we know that your AMI system project may be generating much attention from your board or council, from the media, and maybe even from some members of the community. You may be eager to demonstrate rapid progress by staging a public ceremony after the first water meter is installed, which is fine. If you're deploying an AMI system that does not communicate via a cellular network, however, and if you want to save yourself much time and unnecessary frustration, we recommend that you wait until the network infrastructure has been installed and commissioned across each book or route before commencing mass water meter and endpoint installations. This is especially true for utilities whose water meters are in residential basements, where arranging access to the water meter and endpoints may be challenging. If you want to avoid scheduling repeat visits, it's especially true. You want to avoid them whenever possible. You must make certain that your field crews know how to make a proper splice, and the example that you see at the left is a perfect example of how not to make a field splice. The best field splices involve gel caps and goo tubes. Craig once spent an entire day troubleshooting endpoints because a meter technician thought that you only needed to stick the wires into the gel caps. He didn't know that you had to use splicing pliers to physically press the bar down into the wires for a solid metal-to-metal contact. I recently found some installers who thought you needed to first twist the wires together before inserting the wires into the gel cap. You must use gel cap splicing pliers like you see at the right. Splicing pliers have a stop forged into them to prevent you from applying too much pressure to the gel cap. If you don't use splicing pliers, you risk squirting the gel out of the cap and the splice will not be moisture proof. The field programming tools for AMR and AMI system installation are quite rugged, but they can be broken, damaged, or stolen. You need to clarify who owns the programming tools and who's responsible for their being returned in good condition. In addition to that, each installation crew leader needs to verify that the correct settings have been entered into the field programming tools in the software before any work begins. You don't want to waste time visiting services because one or more settings were reprogrammed incorrectly. If you want to learn all about radio frequency communications and troubleshooting your AMR or AMI system, we recommend you watch the Johnson Controls Blue Water webinar, episode number 11 from October. We devoted an entire episode to that very important topic, and the webinar is available for you on the Johnson Controls YouTube channel in the Water Solutions playlist. You can also send us an email at bluewater@jci.com, and we'll send you the link to watch it. While it's not critical with a mobile AMR system endpoint, it is imperative that all AMI system endpoints be installed either through the meter vault or meter box lid. Using zip ties to mount an endpoint on the rung of a rusty ladder is wrong in so many ways. We also strongly recommend that AMI system endpoints in basements and mechanical rooms are installed on an outside wall above the snow line and away from anything that will impede radio frequency transmission. If you don't want to become a featured story on your local news, it's a very good idea to verify that the meter multipliers are correct for each water meter. The media seems to love stories about account holders who are being overcharged by their water utility. So do your best to stay out of the news cycle by being diligent. Training is such an important part of any successful AMR AMI system project. Your staff should know how to operate the network without any assistance from the provider, and they must develop those basic water meter, endpoint, and software troubleshooting skills. It's important that your staff knows how to order materials correctly and how to use the RMA process. And lastly, your staff needs to know who to contact whenever a problem arises. So we finished covering some critical concerns for AMR and AMI system project installation. And before we invite Dave Rubin from Aclara to tell us more about their AMI system, I'd just like to pause to answer any questions that you might have.
Yeah, Audrey, I know that you covered it in your presentation, but there was a question about should the AMI network be up and fully commissioned prior to the meter changeout. Your thoughts?
I can tell you that it's going to save your installation team, your QA, QC team, and your billing team a lot of time and frustration if you wait until the network is fully deployed.
All right.
Excellent. Are there any more, Craig? I know
yeah, I'm not seeing any right now.
Okay. All right. Well, thank you very much, Audrey and Craig. Definitely appreciate it. So we'd now like to welcome Dave Rubin, who's the product manager for Aclara, to the Blue Water webinar. Dave, I'm going to hand the controls over to you, and I guess while we do that, would you mind telling us more about yourself and how long you've been in the industry?
Sure, of course. My name is Dave Rubin. I am a Senior Director of Product Management at Aclara, specializing in water. I've been at Aclara almost 9 years now. That's my industry as well. Let me see if I can get this to come up in the right place. Tell me that you see my title slide. Great.
Leading AMI technology.
Perfect. So thanks for the opportunity to review both where Aclara is and where Aclara is going. And I must admit, it's fascinating to hear the JCI folks talk about all the lessons learned. I'm like, yep, been through that, addressed that. We see this all the time. Absolutely spot on with all your recommendations. So I guess water is water, and it doesn't really change things. So let me go forward again and talk about where we are. So first, a little bit about, that's interesting. I lost a slide. There we go. My apologies. Let's talk a little bit about Aclara for those of you who aren't really familiar with it. We started back in 1990 as Hexagram, for those of you who recognize that name, And our first AMI system was installed in 1997. So we've been doing this for 25 years now. Lots and lots of experience. I always love the commercial. We've seen a lot, so we know a lot. And there's very few instances that have been talked about already that we haven't come across and tried to solve in our best way. And I will admit we are not perfect for Craig's original pieces, but boy, we sure strive to get closer and closer every year as we continue to innovate. We have been focused exclusively on AMI from day one. So there is no AMR to AMI migration on our side, which brings certainly some benefits to our core technology. I'm not going to go through all this, but I believe these slides will be available after this call. I do want to point out Hubble Hubble acquired us in 2018. So now we're a part of a 100-year-old multi-billion-dollar company. So we're very confident of our financial stability. Not that there were questions, and the size behind Aclara is quite reassuring. So let's talk a little bit about the AMI system as it exists today, and then we'll talk about going forward. This slide is very busy. All this is intended to point out is that the Aclara AMI system is quite capable of multiple processes, multiple products. We are a water, gas, electric capable single network with a whole variety of other things we can add to it, whether it's sensors or controls or so forth and so on. This is very dense on purpose, simply to show all the different things we can do on the Aclara AMI system. But the core of it is very simple. There's an endpoint meter transmission unit attached to the meter. There are data collection units, which is our network, our communications network, and they all come back to the head end. There are no repeaters, there's no mesh, there's no hopping. It's endpoint to collector network to head end. And for an outbound command, it's the opposite, of course, software to collector to endpoint. Very simple, very reliable, lots of redundancy built in, many lessons learned over the years we'll discuss as we go forward. So that's the basis of what we started 25 years ago. It served us very, very well, and we continue to innovate on that network. Some key advantages. It is a licensed spectrum. We will go pull FCC controlled licenses in the name of the utility. The utility will own those licenses. It'll be in your control for the length of your AMI deployment. 450 to 470, we'll talk some more about the advantages that brings. It is utility-owned license, completely under your control. We're meter agnostic. We'll talk about all the different meters we actually have in-house. I have racks and racks of meters that we certify, put on the bench, and guarantee that we can talk to them per some of the lessons learned. It's a proven 20-year battery life. Many of the systems we've deployed early years are still working. Most of them have been replaced. We don't claim 25 years, but we do have quite a few endpoints that have run for 20 years in the field. And then one of the hallmarks of the Aclara design is redundancy, and we'll talk a lot more about what we do to bring redundancy in the network and why it's so important. First, the license frequency advantage. Again, it's protected, owned and controlled by the utility. There is no competition for the airwaves. So I know Craig said be careful for anybody who claims no interference, but these are protected sole use frequencies under your control. And that's a very important piece for why we feel our performance is as good as it gets, is because you are not trying to overcome noise or interference from other sources. It's all within the Aclara system. And of course, we take into account all of our performance. And it is enforced by the FCC. If there's an interloper or an interferer, the FCC will come in with a cease and desist knock on the door, which is quite a large hammer. The 450 to 470 megahertz bandwidth is also very suitable to AMI. This is one of the things that came out from us starting at AMI. Is at that time the engineers stepped back and looked at the entire spectrum and said, what is the best frequency? And we weren't tied to previous technologies. 450 to 470, both the licensing concept and the fact that at a lower frequency it penetrates better, it's lower power for equivalent propagation. All those things really lead to leading performance in a AMI propagation, whether it's within a building, whether it's in a pit, in a basement, all that works very well on 450, 470. And the lower power requirements at the lower frequencies also are a secret to why our battery life is so strong. Network redundancy and resiliency. I've talked about this a few times. I'll talk about it some more. This is a key we found over the years to one of the key ways we make sure that the network is serving your purpose. At the bottom line, the key question is, do you get your data? Do you get your meter reads? So many of the innovations we've done over 25 years have addressed this. Redundancy and of course resiliency throughout the network all leads to better read rates. The DCU network, for example, we design it so it's usually at least every endpoint double covered, sometimes triple covered, i.e. every endpoint is being heard by 3 DCUs. If a DCU goes down, those other DCUs are still picking up the same reading and transmitting them in. Many times our customers don't even know a DCU has gone down other than the reports that say, hey, DCU X is not working, but they'll see no impact to their read rates. There's storage on board the DCU itself. If the backhaul goes down, that DCU continues to collect and will upload automatically when the backhaul comes up. So another way to make sure all your reads do come in. The MTU itself transmits every read twice in 2 separate transmissions, so 6 hours apart, usually in the typical default configuration. So every read not only goes up twice, but goes through 3 DCUs. That's 6 times that reading is transmitted and has a chance to get to the head end. Also, that MTU will store up to 96 days of data on board, and that data is recoverable over the air if there's another issue and you, for whatever reason, have lost some of that data at the head end. You can go back in time up to 3 months and recover data. Benefits, amazing read rates. We have a 6 million endpoint deployment on the West Coast that's getting something like 99.6% hourly read rates. We are not at 100%. Craig is correct. Very few people do 100%, although we do have an installation right now in deployment at 100,000 endpoints that's doing statistically 100% read rate on an hourly basis. So we're approaching it, but we won't claim it because it is very, very difficult, if not impossible, to truly reach 100%. But between the redundancy and the resiliency, we have great stories about surviving hurricanes and any number of other weather issues. The utility can focus on your business needs and not worry about maintaining a network. And then, of course, one of the things I'll talk about towards the end of this talk is future smart water and smart city solutions, or IoT, whatever we want to talk about, all drops into this network, all uses the same infrastructure, and integrates nicely. The key communication, the data collector units, DCUs, they're small, they're inexpensive. They're very flexible in terms of mounting options. It's pretty easy to go find assets. You can drop them on a roof, you can put them on a pole, you put them on a tower or a tank, whatever the case may be, or some mix thereof. But because they're small, it's very easy to go find an asset and then to go put them up. They can be solar or AC powered. You don't necessarily have to have line power there. They include an onboard battery. Because it's small and not a lot of power, we often get 8-day ride through in case of a power outage. For example, if it's an AC powered DCU, we can get 8 days out of that backup battery. And there are a wide choice of backhauls, cellular, fiber, Wi-Fi, whatever the case might be. And then, of course, the endpoint, the water MTU, meter transmission unit. There's a whole bunch of details down the side. That is 25 years of innovation. It's a direct line of evolution from our very first MTU we put in the ground, which, by the way, we still can read the very first model of MTU. There is no stranding of assets. So in terms of backwards compatibility, we still can read very old MTUs with our brand new networks. Compatible with all major water meters. There's a whole variety of things on this I won't go through. There is an AES-256 encryption, 20-year battery life. We do have a dual port version specifically designed for a compound meter, 2 wires, 1 to each register. The MTU handles each one independently. The software can either treat each cable as an independent account, or you can combine them and the software automatically does add those values together to get true compound meter consumption. Along the bottom is just a sampling of the meters that we're proven compatible with. As I said, we bring those meters in-house, we work with the meter manufacturers, we put them on the bench, and then we'll actually certify them as compatible and guarantee the communication between our endpoints and those meters, both by brand and by specific model. And our compatibility list is something like 6 pages long now, includes both pulse and absolute encoders. The software, Aclara 1, this is a relatively new for us within the last 3 or 4 years. It's a brand new piece of software that does both the network management, but also a variety of other options all rolled up under a single umbrella. This is a cloud-based hosted system. There's a couple screens here in a few minutes that goes deeper into what it looks like. We're very excited about the software. It continues to evolve. There's ongoing releases as we add features to it. The advanced metering infrastructure is the network. There's the meter to cache. There's some everything from distribution automation on the electric side, sensors, some of the smart network and smart city things I'll talk about in a little bit. All this rolls up under a single software umbrella, Aclara 1, which means one network for everyone. Feature rich right out of the box, fully cloud hosted, enhanced user experience, events-based, enhanced encryption, continuous improvements. We're doing regular releases to the MDM and quarterly releases to the head end or the network management piece. Intuitive, powerful, flexible, very graphic, includes GIS maps to help track, excuse me, both locations of assets as well as locations of events. In this case, it's pinpoints of, in this particular case, we're looking at leak events based upon severity. So this is a very quick way to get an overview of the status of your system. This is all very configurable, very easy to change in an intuitive sense. And all our customers are finding it a quite powerful tool to help them winnow through what has become masses of data as AMI has become more and more capable. There are quite a few included consumption health analytics. I just listed a few here: water specific, continuous consumption for leaks after the meter, zero consumption, whether it's a tamper or a blocked meter or a broken meter, negative consumption if there's truly a reverse flow or a backwards installed meter again, or a tamper. This is all software generated. We also, one of the things I skipped over is with many of the meter manufacturers, we're also reading and bringing in their meter generated alarms. So you can generate a reverse flow or a leak alarm either through software based upon consumption data or through meter based alarms, just to have better and more alternate ways to determine what is going on at the endpoint. And then of course, cumulative consumption, whether it's a system-wide single number, whether you put groups together. I have all my C&I meters in one group and I want to see what my consumption is. I want to see what it was last week. I want to see what it was a month ago. All that's very configurable, easy to change. And we are also now working on a DMA tool that will continue to bring all these capabilities even further into inflow outflow comparisons to help determine non-revenue water and leakage and tamper and unmetered water. So quite powerful. All this is built into the system today and continues to evolve. Advanced applications. So we've been doing meter to cache, i.e. billing, for many, many, many years. And as most of you will know, there's a strong forward lean now towards everything from IoT, smart network. We call it smart infrastructure solutions. But what can we do with the network further to help improve operations, data management, everything to help you streamline your operation and reduce costs. So one of the first things we did is we did partner up with Guterman, who's a world-renowned acoustic leak detection technology. We bring that system in through the Aclara system using our comms, their logger, our communications, our head end. There's a very nice piece of hardware that goes out and does the typical acoustic leak detection read once a night. listen to the leak sounds on the pipe. We drop it in a valve stack. We bring that back through the network. It's actually becoming quite popular and working very well. That data comes back and goes through our typical GIS mapping in terms of, are the endpoints working, where are they located? We do push the data over to zonescan.net, which is this very comprehensive analytics engine Guterman provides that not only will visualize leaks, but also will locate them. And we're finding with the GPS clock management we're doing out in the field, plus or minus 3 feet is a very typical correlation for a leak using the system. So you're no longer having to dig up an entire road. We'll get you within a pit and most likely find that leak right where we tell you it needs to be. It's working very well, drops right on top of the network. We've also instantiated a remote shutoff valve. This is intended to be at the meter. This is, again, controllable over the Aclara network. Within a couple minutes, you can turn a resident's water on or off with the push of a button. It is connected to an MTU. If you use a short lay length meter, you can still fit it in the standard 7.5-inch lay length, so you don't have to replumb. This is getting more and more traction. The valve has been in the market for a few years. It's quite reliable. We integrated it into our system about 4 years ago, and we're getting some really good response to this. It's a very nice addition. Again, what more can I do with the network to help my operations beyond the meter to cache fundamental functionality? Which brings me to a really exciting development. As we've looked at these IoT, smart network, smart city applications, there became an obvious need for what I call a gateway or communications hub that allows us to attach to any number of other endpoints and bring them through our network to our software. So we're just about to release the first version of what we call our ExactaGuard communications hub. The magic about this is at near field, it's a Bluetooth connection. So we no longer have to cable and wire everything. We're working with a variety of endpoint providers that have added Bluetooth to their sensor. You put this ExactaGuard, you can see what it looks like at the bottom, within about 100 feet. That ExactaGuard hub will read up to 7 sensors of any variety of types as we enable them. I see them close to end of time. And that brings it into the network and then to our head end. So pulse sensor is the first one we're releasing, water pressure monitoring by the end of the year, methane detection by the end of the year, sewer overflow alarm, lots of details in here. And then this is the one I wanted to get to. As we've gone out and discussed this subject, we've been collecting a whole number of asks and needs driven by you, the customer. And these are just some of the things I have on my list that are on our roadmap. That will be enabled by this ExactaGuard, whether it be a smart network idea, and these are all water specific since I'm a water guy, but there's equivalent lists on the gas and the electric side. And then even beyond that to smart city, parking meters, grease trap monitorings, noise monitoring, interesting things I never would have thought of that need that communications network and will leverage our resilient, reliable, covers the full geographic footprint of a utility that you can just drop these on with no problem. We have plenty of bandwidth. So we're very excited about this. It's going to open up a whole variety of new applications that are going to leverage that network even more. So getting to the end, the Aclara summary: experience over 20 years, 25 years now of RF experience, water, gas, electric, license 450 to 470, redundant design, point to multi-point, best technology, simple and reliable, low cost of operation, very resilient, optimized for the AMI application, now smart networks, distribution automation on the electric side, and a trusted advisor. Over 1,000 utilities are under the Aclara brand. We've seen it all, we've done it all. We stand ready to help. We've seen all those issues everybody's been speaking about, and we have experience attacking all those and solving your problems. So that was a lot and a lot of time. I don't know if we have time for questions, but I'm done.
You do have one question, Dave, and that is, would you say Aclara One is more customizable or configurable than, say, the ones offered by the water meter manufacturers?
Oh, that's a good question. And I not being the software expert, I would hesitate to do a comparison. All I can tell you is the times I've worked with the software, the times I've seen the demo, and the times we've trained folks, there's rarely been a time where someone said, can I do this, that we can't say it's either already here, or here's how you change screens, here's how you call up the columns, here's how you filter. Very, very flexible, designed to be both intuitive, visual, and configurable, and customizable per user and per screen.
Okay. All right. I think that's all the questions we had. Audrey, you want to bring us home?
Absolutely, I'd be glad to do that. Please join us for the next Johnson Controls Blue Water webinar on Wednesday, April 19th at 11 a.m. Eastern, 8 a.m. Pacific time. We have an incredible webinar prepared for you next month about being prepared for severe weather. We hope to have someone who's a general superintendent for a water and electric utility that was destroyed completely by an EF4 tornado. And our guest will share with you the lessons learned in being prepared for and recovering from a natural disaster. This is a webinar you can't afford to miss as we move into the spring and all its stormy weather. You can register for the webinar by using the link that you see on the slide, capturing the QR code on the slide with your smartphone, or send us an email at bluewater@jci.com and we'll email the registration links right to you. Very special thank you to Dave Rubin from Aclara. We wish all of you a happy St. Patrick's Day on Friday, and we wish our own Philip Lowry a very happy birthday. We want to remind you to please invite your friends and colleagues to attend the Blue Water webinars, and please submit any topics you want to see us cover in future webinars. We want to know what's important to you and your utility. You can contact us at bluewater@jci.com. Thank you for attending the Johnson Controls Blue Water webinar today. We look forward to seeing you again on April 19th.
Thank you.
Thanks again.
Yes, thank you.